So now in this video we are talking about the intrinsic concentration and the current. So now what is the current? There is a short note that is current. As we know in the electronics, current, that is I, is the rate of change of charge. Rate of change of charge, that is I equals to d, that is differentiation of q according to time, that is t. So that is the rate of change of charge. Q is the current. It is the unit is current of ampere, or Q for coulomb divided by second. So ampere equals to coulomb per second. So the unit is ampere or coulomb per second of the unit of current. Now in semiconductor, you need to remember this point, that is in semiconductor there is a bipolar current. There is bipolar. And in semiconductor, two type of current, that is drift current and diffusion current. So this is small part of this. You need to remember in electronics, for electronics, what is current. Now the next topic is intrinsic concentration. In intrinsic concentration, now in the semiconductor, we know that this is the intrinsic concentration. Now in this topic, intrinsic, what is mean by intrinsic? Intrinsic mean pure. So this is pure concentration of semiconductor. In a pure semiconductor, we already know in mass action law, that is N equals to P equals to Ni. In pure semiconductor, obviously in pure semiconductor, the concentration of electrons equals to concentration of holes, and obviously this is Ni. So that's why we applied N into P equals to Ni square about mass action law. Now in mass action law, what is the value of Ni, we now calculate. Now the main formula of Ni square, that is how to determine the intrinsic concentration. Ni square equals to A naught into T to the power Q e to the power or exponential to the power energy gap at 0 Kelvin divided by K Boltzmann constant into T. So this is the main formula. So I am describing what is T and what is E0. Energy gap, K is the temperature, T is the temperature, K is the Boltzmann constant. Now the formula K, the value of K is, we already know that, and T is the absolute temperature. And the value of K is what? 8.62 into 10 to the power minus 5 in electron per degree Kelvin. This is the Boltzmann constant value in EV per degree Kelvin. 8.62 into 10 to the power minus 5. And in joule per Kelvin is, the value is, we denote K naught, 1.38 into 10 to the power minus 23. This is joule per Kelvin. So now from how this formula is become calculated, now discuss in this video how this formula we are getting. So first we know about the electron concentration. What is the value of electron concentration? That is N. This we already we know that the value of N equals to Nc. This is the constant, e to the power minus Ec minus Ef, that is energy limit of conduction band minus Fermi level energy divided by K into T. One point is that, what is A naught? A naught is the material constant. This is the constant of material constant, and it is independent of temperature. So now this is N. Nc is a constant term, exponential to the power minus EC, that is, if we diagram the energy band diagram here, the energy band diagram. Now here this is the conduction band, so the energy is EC, we denoted as, and here's the valence band, so this is EV. Now this is Fermi level, this is denoted EF. So this is EC minus EF, that is the electron concentration by kT. And what is the value of P? That is the whole concentration. N V, this is the constant term again. Here e to the power, here E, here in bracket, this is the value of this is EF minus EV, that is valence band energy, by kT, that is EV, EF minus EV, this part, and this is this part. So this is the energy gap, energy band diagram. So now in the mass action law, we get that N into P equals to Ni whole square. Now what is the value of Ni square? Becomes Ni square equals to Nc into Nv into e to the power. If we calculate this, this becomes e to the power minus Ec minus EV by kT. What is EC and EV? This is the conduction band energy and the valence band energy. Now if we minus this EC minus EV, this is energy gap, that is we denote Eg. So this becomes Nc Nv e to the power minus Eg by kT. Now Nc and Nv always constant, and this depend on temperature. Now from this, the constant terms become A naught into T to the power Q into e to the power minus Eg by kT. By this formula is become. This is very important formula to calculate the intrinsic concentration. So here the intrinsic concentration, that is Ni, is between the two function. Is a two function of what? One is temperature, another one is energy gap at 0 Kelvin. So this is depend only two type, Eg0 and temperature. Now this equation also we can write that is N square, and 2 the square is transferred to here, so root over A naught T to the power 3 by 2 e to the power minus Eg naught by 2 kT. The 2 becomes divided here, and divided here. So this is become roots. This is also the formula. So now up to this is the formula of intrinsic concentration. Now what is the dependency of intrinsic concentration on the temperature? Intrinsic concentration Ni is proportional to T to the power 3 by 2, as we see here. This is the dependency on temperature. Now another point that is note here, the intrinsic concentration of silicon is less than the intrinsic concentration of germanium, because energy gap of silicon is less than germanium. So that's why the value is also less. So for germanium the value is here. For germanium the Ni intrinsic concentration 2.5 into 10 to the power 13 per centimeter cube is the you need to remember or not. And for silicon the Ni value is 1.5 into 10 to the power 10 per centimeter cube. Now some questions here we need to understand about this topic to solving some numerical problems. So now if they calculated the Ni, that is intrinsic concentration, at 500 Kelvin. The formula is look like this. That is, we know the formula Ni. Here Ni equals to root over A naught into the temperature to the power 3 by 3. So T, how to substitute T in 500 Kelvin? Now there is a absolute temperature. To make this absolute temperature, we divided by 300. So now 500 Kelvin they are given for Ni, and for absolute this is making dividing by 300 Kelvin. So this is become absolute temperature, and T to the power we know that 3 by 2. Now E exponential to the power E g naught according to the formula by 2k. Now again the temperature, that is 500 Kelvin given here, and for absolute making we get the divide by 300. This 300 Kelvin is the absolute temperature. For to making this we divide by 300. Now if the question is here to calculate the Ni, that is intrinsic concentration, at T equals to 200 Kelvin, or temperature given here 200 Kelvin, then the value becomes Ni equals to again root over A naught into 200, here 200, to making this absolute divided by 300 all to the power 3 by 2 into e to the power minus e g naught divided by 2k 200 by again temperature 300. By this we get the value of Ni at different temperature. So now again some problem we are doing, and in your screen a problem is shown. Check this problem and write down your notebook, then solve this. Now the problem is statement that calculate the value of intrinsic concentration, that is Ni, in a silicon for Si sample which is kept at, that is the temperature at 550, that is 550 degree Kelvin. Now assuming Nc equals to 2.8 into 10 to the power 19 per centimeter cube, and given here Nv equals to 1.04 into 10 to the power 19 per centimeter cube, and energy gap given at 0 Kelvin, that is energy gap 1.12 electron volt at 300 degree Kelvin. So now how to solve this? Let's check. At T equals to 500, the intrinsic carrier concentration is found in equation as. We know that the equation Ni equals to Nc Nv into exponential minus Eg by Kt. Now here they given that at 300 degree Kelvin the energy gap is 1.12. So now the value is becoming here, put the value Nc 2.8 into 10 to the power minus 19 into Nv, that is 1.04 into 10 to the power 19. Now the temperature, for the temperature increasing, temperature is here 550 they given, 550 divided by 300 to the power whole cube, the Ni square, the value is Ni square. So this is, we get the Ni square. Now into exponential, that is e to the power minus energy gap value, that is 1.12 electron volt divided by k. The k value of k is, we know already the value of k in short form we get the 0.0259. This is the short form of the value after the calculating, that is 0.0259 into temperature. What is the value of temperature? 550 divided by 300. So after calculating this, we get that Ni square equals to 1.02 into 10 to the power 29. Now for what is the Ni? Then the root over, that is 3.20, this becomes into 10 to the power 14 centimeter per centimeter cube. So this is the answer of this question. So in the next video, we will discuss about the efficiency or Einstein equations. Up to this intrinsic concentration is end. Now let's take another important question. In your screen, the question is shows here. Now here the question is that consider the material X and Y. There are two materials, there is X and Y. X has a band gap of 1 electron volt and Y has the band gap 5 electron volt. But both are in 300 degree Kelvin, that is both are in absolute temperature already. Now calculate the ratio, that is the ratio of Ni y. Calculate the intrinsic carrier concentration of material Y to X, that means Ni by intrinsic carrier concentration of X. This is the ratio. What is the ratio? This is fine. Now as we know, that is the for Ni square, the value is A naught T cube into e to the power minus Eg at 0, that is 0 Kelvin, by K into T. Now for Nix, let's suppose for X material, the square equals to A naught T cube. As we know, the T is become 300 by 300, so always it is 1 because 300 Kelvin by 300. E to the power minus, here the band gap is 1 for X, divided by 0.026, this is the value of K, into 1, that is the temperature, because temperature of absolute temperature here is given in the energy gap at 300 Kelvin also, for 300 by 300 for making it absolute, so that's why this is 1. Now for Ni Y material, this intrinsic carrier concentration for Y material square equals to A naught T to the power cube e to the power minus 1. Here the energy gap is 5 given, divided by 0.026 into 1. Now divide this equation by this equation. So now Y, that is 2 by 1. We get that the value is become Ni square by Nix square equals to 1.532 into 10 to the power minus 67. So what is the answer? Answer is Niy by Nix. This is the ratio. That square is here. Now this becomes, the value is becomes 3.9 into 10 to the power minus 34. So while dividing, A naught and A naught both are cancelled, T cube also cancelled, only exponential part are there. Now you need to calculate on your calculator and the values become this, and after that you root over this to get the answer. Thank you.